In example 3, we're going to state the domain and range and write the solution in interval notation. So for the domain, we want all the values of x. So -2 is 1, 0, 2, and 3. Remember to state just an individual point. In interval notation, we're just going to write the point down twice and include it in brackets. We need to connect or make a union with the other ones. So this is 0, 2, and 3. Kind of a tricky one. Try to use a different color here. So the range, that's going to be all the y values. Let's start off with the lowest one. So there's a -1. The next one is right here, and the value here is 1. And again, we're only looking at the y values. Oops, twist it a little bit. There we go. The next one is 2. And the next one would be 3. So these kind of look similar, but the deal is that the domain are the possible values of x, and the range is the possible values of y. If we take a look at the next one, the domain is all the possible values of x. We're imagining that this keeps on going to the left here, so you should probably draw an arrowhead there. And -infinity would work. All of these values are defined for the function. -1 would work, and actually this is not a function because -1 has 2 outputs. This value of x works, so any real number will work for the domain. In interval notation, we write that -infinity to infinity. Even though there's a gap here, if we only look left to right, there really is no gap left to right. Any x value here has a point on the graph. The range will be a little bit different. So for the range, you want to start with the lowest value. That's -infinity up to and including 1. We have this gap here of some values that do not exist. And then we only have one value here that the graph exists at for the y, and that's 4. So we want to write that as 4, 4 with brackets surrounding it. Got a couple more examples to do here in example 3. And actually there's a few more. Oh, we got a number of them. So let's do the next two, and I think we have 4 more after that. So this one, again, we're imagining that there is arrowheads here. There should be arrowheads. So we want to state the domain. The domain is any value. For this is straight line, so any value of x will work. So we're -infinity to infinity. That's all real numbers. And actually the same thing for the range. If we look up and down, we don't see any gaps in the y. Any value of y is possible. So the range will be -infinity to infinity also. If we look at the next one, this one happens to not be a function. At 0 there's 2 outputs, 1 and 3. But if we're looking at only the domain, all numbers from -infinity up to this point work, and then any number past that works too. So this one is going to be -infinity to infinity. The range is a little more interesting. The lowest number the graph exists at is 1, and it only exists at 1. There's a gap here, so here's our union symbol. And then 3 is the next value. With this graph on the left-hand side, the domain is going to be all real numbers. As we continue on this graph, there's no gaps in the x direction. So it'll be -infinity to infinity. The possible y values, the first possible y value is -2. and this graph covers all the values here up to 3. So the range is going to be, oops, we want to include that, scratch that off, -2 because this is filled in, and then we want to include 3 also. Let's look at the next graph. I'll move this over just a bit for you so you can see it. There we are. So the domain for this one, from -infinity, and then even at 3, the function's defined here, and then we just keep going to the right. So all these x values will work. The domain is -infinity to infinity. The range, we only have 2 possible values for y. That's 1 and 3. So the range is going to be 1 and 3. Even though this is not filled in, for an input of 2, the output is 1, and so 1 is a possibility, even though this specific point on the graph doesn't work. We're only looking at the values of y and what those possibilities are. For this graph, again, we're imagining that we have some arrowheads here. The domain is all of these x values. All these x values, even all the ones in the middle, have points on the graph. Even at 1, the function is defined. It's 4. And as we continue to the right, all these numbers work too. So the domain is -infinity to infinity. The range then for this, all the values from -infinity up to 0 work. Even 0 has a point. And then those values continue up to 4. The graph doesn't exist anywhere up here. Even though there looks like there's a gap here, all these values here that are in the gap are also covered. You can see that all of these values are defined here. So the range is from -infinity up to and including 4. With the graph on the right, got a nice little parabola here. And I'll move that over just a touch. There we go, so you can see it. Nice. So the domain here, this graph is defined for all x values. So again, another -infinity to infinity for the domain. Oops, move that a little bit on you. And for the range, this graph begins at 0 and then continues to infinity. And 0 is a point right here that's on the graph, so we want to include it. And then the possible values of y just are all the ones that are up here, so all the way to infinity.